Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's explore infrastructure orchestration. So provisioning infrastructure and configuring the provisioned infrastructure are two major tasks of DevOps engineering. Of course, there are a lot of tools in the market. Some companies start with Terraform. They use Terraform for infrastructure management. But when they start using Terraform for configuration management as well, they realize it's not a scalable solution. To be precise, Terraform provisioners can configure the infrastructure, but at scale, they are not reliable. In the same way, some companies start with Ansible. Ansible works great for configuration management, but when you start using Ansible for provisioning infrastructure, you realize it's not as matured as Terraform. So overall, what a lot of companies do, they end up looking for a solution which can blend Terraform and Ansible. So they need an orchestrator which can combine Terraform with Ansible. In today's video, we will learn about one such orchestrator. Now, what does this orchestrator do? Orchestrator 1 defines the order of execution. A lot of times, Ansible playbooks needs to be executed once Terraform creates the resources and these resources are ready. Orchestrator can help you with the order of execution. 2, policy management. This is super important. Imagine you have a policy, compliance, or governance restriction at your company where you are not allowed to create an EC2 instance with all the inbound traffic open. How do you enforce such policy? An orchestrator can help you enforce the policies where you can restrict users from creating resources out of your company's compliance. 3, a strict RBAC. Now, when you combine Terraform with Ansible, it's a very powerful solution. You don't want everyone in your organization to get hands onto it. So you need a strict RBAC, and orchestrator can help you with such RBAC. In today's video, we will learn about infrastructure orchestrator, which is leading in this space. That is Spacelift. So Spacelift is an orchestrator that can combine Terraform with Ansible, and it helps you provision the infrastructure, configure the infrastructure, and also enforce policies and RBAC. Not only that, Spacelift also supports Terragrunt, CloudFormation templates, Pulumi, Kubernetes, so that you can use tools of your choice. Without any further delay, let's learn how to use Spacelift, and I'll also show you a very interesting demo in today's video. Perfect. Let's get started. So let's use Spacelift and create Terraform as well as Ansible stacks. We'll also establish dependency between these stacks so that Ansible playbooks are executed once Terraform resources are successfully created. For the purpose of demo, I have created this GitHub repository and I have already hosted Terraform and Ansible files in it. Reason for doing it, we don't have to focus on writing these files in the video, but rather we can focus on the main problem, how to orchestrate Terraform with Ansible in an enterprise way. Let me quickly go through these files for you. So TF is basically Terraform folder. The main file here is the main.tf, which has code to create EC2 instances. And these EC2 instances are mounted with a public key file. Reference is taken from variables.tf. There is also outputs.tf, which is used to print the external IP addresses of created EC2 instances on the terminal. Similarly, there is also Ansible folder where I have two simple playbook files. We'll be using install htop.yaml So what this playbook does, when executed, it will take all the host names from the inventory file and install htstop on all of those virtual machines. Now imagine you have to perform the same task without Spacelift, or you don't have an infrastructure orchestrator. Then as a DevOps engineer, or as someone who is managing the infrastructure at your organization, you need to build an internal tool, and this tool has to take care of a lot of things for you. Now, this tool should take care of installing Terraform and Ansible, and also it has to make sure the version of Terraform and Ansible are always up to date. So not only installing, but this tool also has to take care of continuous upgrades of Terraform and Ansible. Along with that, this tool also has to make sure order of execution is maintained. What does that mean? As I explained during the introduction, Ansible playbooks should be executed once Terraform resources are created. Why? In our example, the one that we are using for the demo, 3 EC2 instances are created. Now, once these instances are created, Terraform will output the IP address of these instances. Tool has to take care of populating this information in the inventory file so that Ansible can read the host names from the inventory file. So this is a very important thing that the tool has to perform. Otherwise, Ansible playbook execution will be a failure. Along with that, policy management. As I told you, this is very important. For your proof of concepts or demos, you might not worry a lot about policy management. But when it comes to enterprise, there are set defined rules, compliance, and governance. Tool has to make sure strict policies are enforced. As I told during the introduction, maybe the EC2 instances created by this Terraform instance should not allow all inbound traffic. And just like policy management, RBAC is also very important. Imagine everyone gets access to this tool. Now, this tool also has cloud integration, right? So for Terraform or Ansible to install and configure, this tool has to be configured with AWS, Azure, or any public cloud platform. So imagine everyone gets access to the tool. So they are going to create resources on the cloud platform. So now to perform all of these things or to develop such a tool is a huge amount of work. Instead, organizations can go for Spacelift. I hope the problem statement is clear and you all understand why infrastructure orchestrators such as Spacelift are important. And why we are going to use Spacelift in today's video? When we head to the demonstration part, you will realize how Spacelift is going to make all of this super simple for you. Because it takes care of installation and configuration, right? It will upgrade your Terraform and Ansible if required. It will also take care of order of execution, policy management, RBAC, and much more. So we will be covering especially that during the demonstration part. To create an account with Spacelift, you can use the link in the description or pinned comment. If you want to use it as a single person, it's absolutely free. You can perform your proof of concepts. You can test Spacelift for no cost. But when you want to use it within your enterprise or within a team in your enterprise, you can upgrade to their enterprise version. For this demo, let's proceed with the free account. I already have one, so I'll just proceed with that. You can use your Google account to sign up for the free account. Now, before we start creating the stacks, it's important for you to understand what exactly is a stack, what is a space in Spacelift, what are contexts, what is cloud integration. So let's understand building blocks of Spacelift or the primary components of Spacelift. So these are the ones which you need to understand to get started. First one is a stack. So stack is the primary building block of Spacelift. What you do with stack, you basically integrate your version control system. For example, in our case, we will be using a Terraform stack and Ansible stack. Within the Terraform stack, we will integrate the version control system where Terraform code is hosted with the tool called Terraform. So within stack, you can use variety of tools that Spacelift supports. And you can also define where this action has to be executed, right? For example, AWS in our case. Then coming to the spaces. So spaces are like workspaces, or they are like containers where all your Spacelift components are going to be created. Let's say you have two different teams, or you have a developer workspace, you have staging workspace. So you can just create two spaces within Spacelift, and within the dev space, you can create all the components that are related to your dev environment, all the resources that are related to your dev environment. Coming to context, context is very simple. Let's say you want to create some variables, or let's say you want to create some volumes, or you want to share some files across different stacks in your Spacelift. You can just create that as part of context, and context can be shared across the stacks. Typical example, variables or some files. Cloud integration. Now this is very obvious. End of the day, you are creating infrastructure on public cloud platforms like AWS, Azure, or GCP. So within your spaces, you can integrate the cloud providers. This is a one-time activity for your space. Once you do it, then you can start defining your Terraform as well as Ansible stacks. Finally, policies. I've explained this a couple of times in the video already. So you can define or enforce policies related to your infrastructure within Spacelift. Now that you understood these concepts, let's proceed with creating Terraform stack. But before that, what you need to create? You need to create a space. By default, there is a root space. I created something called test.org. But for this demo, I'll create a space called dev console. Just a random name. You can provide anything. You need to define a parent space. I'll use the root as a parent space. Parent space can, or it has access to the child spaces. So I'll just create this space. Now within this space, I'm going to create the complete infrastructure, and I'm also going to define Ansible stack. We will use some context, right? For example, if you look at our Terraform code. So within Terraform, we are mounting the public key onto the EC2 instances. So this has to be shared with Terraform as well as Ansible. On the EC2 instances, we will mount this public key, and this key is also important for your Ansible to connect to the EC2 instances, right? End of the day, they connect using the public private key. So what we will do is we will use the PEM file as a context so that we can share the PEM file across two different stacks. It's very simple, right? So whenever you are creating EC2 instances, these instances should be populated with the public key, and Ansible should have access to these instances. So what we will do, we will provide Ansible with the PEM file. So, or with the private key. So overall, public key and private key has to be shared through the stacks, between the stacks, using the context. So to do that, we will head to the context, right? So we will say Ansible key. So I've created a public key and private key on my local machine that is using SSH keygen, and I have mounted IDRSA as well as IDRSA.pub, which is public and private keys. You can also do it at your end. Just create using SSH keygen and mount those files as context. Provide the name as Ansible key for easy reference. Don't worry, I'll also share the document with you. In case if you want to do the exact same demo, you can find a link in the description where you can follow the series of steps that I'm going to perform during the demonstration. Okay, so now we have the spaces. We also have the context. So what I'll do is I'll just move the context from text org to the dev console, because we are going to create the stack within the dev console. Okay, so let's head to the stacks. Let's create a stack. I'll call it as Terraform stack. I'll put this in the dev console space. Perfect. Let's click on continue. Great. We need to provide the Git URL. Okay, so this is the one. Spacelift demo. Copy the URL. Perfect. So it automatically populated the repository name, user namespace, project root. This is important because the Terraform code is not available at the root of the repository, but it is within the TF folder. So I'll just copy the relative path. Okay, just remove the spaces. Perfect. We are good. Continue. Which tool do we want to integrate to? If you remember the theory part, I explained within the stack, you integrate the version control system with the tool. Now, what is the tool that you want to integrate it to? I want to integrate it with Terraform. So I'll just select OpenTofu or Terraform, and within the workflow tool, I'll select Terraform. You can choose a specific version or a range. Okay, I'm good with it. Click on create and continue. You can define the behavior of stack. You can define hooks to your stack. That is any actions that need to be executed before or after. For now, I don't have any hooks. If required, I'll create that later. Attach cloud. This is needed because you need to integrate your stack with the cloud provider. What I'll do, I'll just complete the creation of stack. Then I'll go back and integrate my cloud provider with it. You don't have to do it during the creation of stack. You can always do it once the stack is created. Okay. Right now, I don't want to attach any policies. Context. Let's pick up Ansible key as a context. Continue. Perfect. Confirm. So now we have our Terraform stack created. However, it is of no use without the cloud integration. So let's proceed with the cloud integration. Setup integration, AWS. I'll call this as dev console. Within the dev console space, it asks for a role URN, Amazon resource number. So what I'll do, I'll go to my AWS account. I'll head to IAM and I will create a new role. Steps are very simple. So you can just create a new role and follow the instructions that are provided in Spacelift. Okay, so to create a new role, head to the roles, create role. So the default trusted entity type is AWS service, but what we are going to use is the Spacelift account. So instead of AWS service, just choose custom trust policy. Now you might wonder, but Abhishek, what do I put within the custom trust policy? Just go to your Spacelift cloud integration part. You will find the trust policy that you need to place. So just copy this entire thing, go back to your Spacelift account, my bad, AWS account. Just replace the custom trust policy with the one that you copied. Perfect. Now click on next. You can grant administrator access, or you can be very specific what cloud resources is your stack going to use. I'll delete this role once I'm done with the demonstration. So I just choose administrative access. And you also have to provide a name for the role. So I'll choose the same thing, dev console. Rest all looks good. So I'll proceed with create a role. Now that the role is created, you can go back to the cloud integrations, right? You can just copy the ARN for the dev console. There is a specific ARN, just copy it, go back, paste it here, and click on the setup button. So if you see that the cloud integration setup is successful, you are good to go. So if we go back and get back to our stack, the Terraform stack that we have created, go to the details, settings, integrations, and you can integrate or attach your cloud integration. So AWS and provide dev console, whatever we just created. I would like to grant the read and write access, attach. Again, if you haven't configured the right trust policy, even at this point, your cloud integration would fail. So just follow the same steps and copy the trust policy that is provided by Spacelift. Most likely, you will not run into any issue. Now we have created the Terraform stack. Let's try to verify if everything is working fine. Before we create a stack for Ansible and we try to establish a dependency and execute the Ansible stack, let's verify if everything is good with Terraform stack. If everything works fine, it has to create 3 instances on our AWS account. Let me quickly show you. If I switch to EC2, so right now I don't have any instances, right? You can see the running instances as 0. Perfect. Going back to Spacelift, click on the trigger. Yeah, so we are good. If there are any webhooks, like if you have configured any hook to execute before your stack execution, you would see the hooks being executed. But right now, it is initializing Terraform, finding latest version of the HashiCorp AWS provider. Now, if you observe this entire process carefully, I haven't installed Terraform on my local machine. I haven't configured anything related to the provider. Everything is taken care by the platform. And you can see here, it identified that, okay, this is your Terraform HCL files. 4 resources are being created, right? And it also started creating the EC2 instances. AWS instances, IP address is known after the apply, and the same thing. If you want to stop the execution at any point of time, you have this stop button. Now, if you're wondering, Abhishek, how about state file management? Because when it comes to Terraform, state file management is the key aspect. So there are 2 ways to deal with it. One, you can manage your own state file, or you can also use Spacelift to manage the state file. And if you use the enterprise version of Spacelift, another advantage that you can get, it also helps you with the drift detection. Perfect. So it is saying applying the changes. Let's see if our instances are being created. So we have the instances created. It just took, I think, less than 30-40 seconds. So these are the IP addresses of the instances. You can see it on terminal because we have configured outputs.tf. If I go to my AWS, just refresh. So I should have 3 instances running. Perfect. So we have all the 3 instances in the running state. Now, let's go ahead and configure the Ansible stack. Because we are good with Terraform, we haven't done anything except writing the HCL files or the Terraform files. Let's see what is the case with Ansible. Now, this is the difficult part of the entire proof of concept that we are doing, because Ansible execution depends entirely on Terraform. You have to make sure the hosts that are created. So if you look at Spacelift, these are the 3 external IP addresses. You have to make sure these IP addresses are configured in the Ansible inventory file. I'll show you how you can do it. So again, we'll go back to stacks. So we'll click on create stack. This time, let me call it as Ansible stack. We'll put this in the same space. So I'll use the dev console for the Ansible stack as well. Click on continue. GitHub repository. So copy. Perfect. Let me paste this here. And we also have to provide the project root. So going back, Terraform stack dependencies, Ansible. So we'll copy the path from here. So we have done the exact same thing while we were configuring Terraform stack. Great. So let's proceed. I'll click on the continue. Now we will define the behavior of the stack. So the tool that we are going to use is Ansible. Okay. It asks for the name of the playbook. As I explained you before, there are 2 playbooks here. I'll just use install htstop.yaml so that htstop is installed on all 3 of the EC2 instances. We'll start defining the stack behavior. So just mask the secrets. That is good enough for the default things. But when it comes to hooks, we need the hooks here. Why? As I explained you, now once Terraform execution is done, so Terraform prints the output, or you have the EC2 instance IP address. Now these instance IP addresses should be put in the Ansible inventory file. So what we will do, we will use the Spacelift hooks. So we'll actually use the before hook, right? Where within the before hook, we will run few commands. And what these commands would do, it would create an inventory file for us. And within the inventory file, within all, we will put the EC2 instance public IP addresses. It's very simple. So we just have to run few commands within the before stage. So the first command that we will run, so we will grant permissions to the private key, right? So private key will do the communication part. It will connect to the EC2 instances. So first we will use the private key and we'll grant the permissions. Then what we will do is we will start creating the inventory.ini file. As I told you, I'll share these commands with you. I'll actually share you a document where you can find all the things that I'm executing in order. And finally, we'll use a simple for loop, which loops over the instances. So instances is the output of your Terraform, and it just adds those public IP addresses into the inventory.ini file. We don't need any after hook, right? Because once the Ansible is executed, we are not sending any notifications. So right now, no after hook is needed. And yeah, we will need the AWS integration. Just like the previous one, let's grant read and write access. Now the AWS integration is successful. So let's head to the next step. Any policies? Right now, we are not dealing with any policies, but we need the context. Context is the Ansible key. And we have already granted permissions to the Ansible key within before hook. Perfect. So let's just cross verify. Hooks are added, cloud integration is added, Context was not added. So let me just try to add it one more time. Attach. Okay, now the context is added successfully. Let's re-verify everything is in place. So the source code looks good, behavior, all good, initialization, cloud integration, and context. Great. Now that we have both the stacks, let's head to Terraform stack and define the dependency. So this is what we were talking all about, right? The dependency between the stacks, so that once the Terraform execution is done, Ansible playbooks are executed by default. So how do we do that? Again, just go back to the stacks, go to the Terraform stack, dependencies. What you need to do within the Terraform stack, depended on by. So here you can just add a dependency and select Ansible. You can also do it using the dependency graphs, right? And the other thing that you have to do is within the output reference, select AWS instances. So what happens? Once the Terraform execution is done, it invokes the Ansible playbooks by default, and it also shares AWS instances, which is the public IP addresses of the instances as the output to or input to the Ansible context. Perfect. Let's provide a name for it. I'll just call it as instances and add it. Okay, now we have also added the dependencies, but one thing that I missed while creating the Ansible stack was to add few environment variables. When we created the Ansible stack, we missed to add the location of the Ansible inventory file. We missed to add the location of the private key file and the remote user. It's very simple. Go to the Ansible stack, head to the environment, and just add the environment variables. So the first one that you add is Ansible private key file. So Ansible private key file would be /mount workspace IDRSA. Great. And finally, the last one is Ansible remote user. So Ansible remote user, you need it for the execution, right? So we'll use Ansible remote user and we will just select it as Ubuntu. Great. So just refresh the environment variable page to make sure your environment variables are updated. Okay, so we have Ansible private key file, we have Ansible remote user. Looks like the Ansible inventory is not added. So let's try to add it back. Add variable, Ansible inventory. So it is /mnt workspace inventory.ini. Great. So now we have all three environment variables that are required. Perfect. Now let's also verify if Ansible stack is executed. So for that, I'll go to Ansible and I'll just trigger it. Or you can also trigger the Terraform invocation because you added the dependency. So as you execute Terraform stack, Ansible stack should be executed by default. Anything is fine. So you can see here, Ansible execution is complete and it has installed package headstop on all the three instances, right? It says the execution is successful. Okay. The three EC2 instances now have headstop package. We can also just verify that. So we can just go to the instances. So let's just pick up one of the instance, connect to it. And let's just see if headstop is installed on it. So I'll just try to run headstop and there you go. Tada! So we have headstop package installed. Now that we have integrated Terraform and Ansible stacks, we have set up the stack dependency. Going ahead, if a DevOps engineer adds a new EC2 instance, Ansible playbook is invoked, and even on the new C2 instance, you will have htop package installed. For example, let's go to the GitHub account and we will try to add a new instance. So I'll go to the Terraform code within main.tf. Let me just update one more instance. So within the locals, I'll just add instance 4. So I'll just call it as instance 4 and I'll keep rest all the same. The Ubuntu AMI ID, instance type, only thing that would change is I'm going to add a new instance, right? I'll commit this change. Perfect. Now let's go to Spacelift, right? And I'll just re-trigger this. Although you can also integrate it for a continuous integration, continuous delivery approach. So you can also ask Spacelift to trigger Terraform stack every time there is a change in the GitHub repository. So now that we have these IP addresses, let's head to the Ansible stack. And you can see, great. So Ansible now configured htop on the newly created or this fourth instance. You can check the IP addresses are exactly the same, right? So on 4 of these instances, now htop is configured. This is how you can perform continuous infrastructure orchestration. Now, if you are stuck somewhere, or let's say you are not able to follow the demonstration, I'll share all the useful links in the description. So Spacelift have a lot of blogs. So they have set up blogs on their website, spacelift.io/blog. So I'll be sharing bunch of blogs that you can go through, which contains everything, how to create Terraform stack, how to create Ansible stack, and all the configurations that I have done in the video. Also, if you're interested in tracking the failed stack runs, so Spacelift also supports observability. So you can see they have metrics. So within the metrics, you can track number of Terraform executions, how many of those executions were successful. You can see the time of the deployments, everything through their observability dashboard. If you upgrade to the enterprise version, you can also get the diff detection. In today's video, I'll not be covering policies because this is a very first episode of Spacelift. So I don't want to confuse you with so many concepts. In the future lessons, I'll talk about policies, how you can enforce a specific policy using Spacelift. But for today's video, I hope everything is clear. If you have any questions, do let me know in the comment section. Don't miss to explore Spacelift. Again, the link is in the description and the pinned comment. See you all in the next video. Take care. Bye-bye.